Hello everyone, I'm making this video to talk more about our two-column proofs to give a little more explanation from yesterday. I'm going to be doing 4 tips in what I recommend you do during your two-column proofs, and along with those 4 tips I'm going to give an example of a two-column proof from start to finish to go with it. As you can see here, the example I'm going to do is going to be the given. Angle 2 is congruent to angle 3, and I'm trying to prove angle 1 and angle 3 are supplementary. I've got a little picture here to go along with it, angles 1, angles 2, angle 3. So first out, to start with the tips, I'm going to give you the first tip, and that is know the postulates, theorems, definitions, and properties. So know the postulates, theorems, of course I can't spell theorems right, definitions, and properties. All right, and you might want to write these tips down as well, and this two-column proof that's going along with it. All right, so know the postulates, theorems, definitions, and properties. This is probably the biggest tip I can recommend, because knowing what to do with your two-column proof requires you to know your postulates, theorems, definitions, and properties. Now, when I say know them, that doesn't mean you have to have them all memorized. That doesn't mean you have to know them word for word or know every single name. What you do have to be able to do is know how to find them. So for example, your properties. You can find your properties in page 104 in your book. Those will show you your properties of your equality. And so having that alongside you while you do your two-column proofs can be very useful. If you're looking for your postulates and theorems, they're in the back of the book. Chapter 2 is page PT3. Those can be useful in finding those postulates and theorems that you want to apply as well. And your definitions. We used some definitions yesterday as well. You're going to use the definitions a lot. Especially at the beginning. You can find your definitions in the glossary or from your notes. If you've taken good notes over our definitions that we've learned so far, you can find those from there as well. So having those alongside you while you do your two-column proofs will help you out a lot, and they'll help you know where to go. My second tip is going to be to label the drawing. Label the drawing. Labeling the drawing is a great way to start, and when you don't know where to go, labeling the drawing can sometimes just be that easy step to help you towards the right direction. So in this example, I'm going to take my givens, which says angle 2 is congruent to angle 3, and I'm just going to label that drawing with markings here to notate angle 2 is congruent to angle 3. And I know my drawing's kind of bad. They don't look congruent, but just imagine that they are. That's all I can say. My drawings aren't perfect, but with that notation, that's telling me they're congruent. Even though my picture isn't perfect, at least I know that to be true. So I'm going to label my drawing. Of course, sometimes it can be simple labeling that helps. Otherwise, you may have more things to label in your given, but labeling the drawing can really help you out in this process, or even creating the drawing if there is no drawing. My third step is to know where you're going. Know where you're going. This is important because if you don't know where you're going, then you're going to start off going in the wrong direction, right? It's like a GPS. If you don't have a GPS and I just told you to drive, you wouldn't know where to go. So we got to know where we're going. So when I want to know where I want to go, I'm going to start out by creating my two-column proof. I'll start with my statements on the left, my reasons on the right. There we go. Statements and reasons. Of course, I can start out by labeling the simple one. Of course, that's the given. My given in this was angle 2 is congruent to angle 3. Reason was given. Now, the next thing I can do is I can apply step 3, and that is know where you're going. I'm trying to prove angles 1 and angle 3 are supplementary. Angle 1 and angle 3 are supplementary. So that's my destination. That's where I'm trying to go. That's what I'm trying to prove. And again, I don't know what step that's going to be, so I'll just leave that blank for now, and I'm going to try to fill in the middle. And I don't know how I'm going to get there, so I don't know my reason yet either. But we're going to get there. And that leads me to my fourth tip. My fourth tip is that the given is always given for a reason. The given is always given. Oops. is always given for a reason. All right, the given is always given for a reason. There's a reason they told us angle 2 is congruent to angle 3. We're going to use that piece of information. It's probably going to come in the next step or two. So when I'm coming up with the next step to go from here, what I want to think of this as is an if-then statement. If angle 2 is congruent to angle 3, then what? What can I say based on that statement? If angle 2 is congruent to angle 3. And you can treat it simply. You can just say, if angle 2 is congruent to angle 3, then the measure of angle 2 is equal to the measure of angle 3. The measure of angle 2 is equal to the measure of angle 3. It's a simple statement. These two are congruent, therefore their measures are equal. Then I ask myself, how did I come to that conclusion? What property, postulate, theorem, or definition did I use? Well, here I used my definition of congruent angles. Definition of congruent angles. I'm going to abbreviate that to definition of congruent angles. Definition of congruent angles. All right. So there I've created my first step based off this given information. My first step based off this given information. Now I'm going to work through that process of statements, just like those if-then statements, to go down this list and try to get to this conclusion. All right. Now I said I had 4 tips, but I'm actually going to add a 5th tip, a bonus tip. My bonus tip to you is this, number 5. If you're stuck, think backwards from the proven statement. From the proven. If you're stuck, think backwards from your proven statement. So if I'm trying to prove angle 1 and angle 3 are supplementary, I'm probably going to have to say along the line somewhere that angle 1 plus angle 2, or angles 1 plus angles 3 are equal to 180. That was my definition of supplementary, right? So I'm going to go up a step, and I'm going to have to say, before that, I'm going to have to say that these two add together equals 180. So I'm kind of working backwards. If you think of it like a maze, you can a lot of times use pencil mazes. Sometimes it's easier to solve the maze going backwards. So think of it like that, and eventually you'll kind of meet up in the middle. All right, so I'm going to try to prove angle 1 plus angle 3 add up to 180. I'm trying to prove that these add up to 180. And I can already conclude from this reasoning that angle 1 and angle 3 are supplementary based on the definition of supplementary angles. Definition of supplementary angles. I just used the definition of supplementary angles to get to this step to this step. So along here, I need to be able to say measure of angle 2 equals measure of angle 3. I need to be able to say measure of angle 1 plus measure of angle 3 is equal to 180. Well, I am going to use a little trick on step 3 here. And that is, I'm going to be able to say angle 1 plus angle 2. Oops, sorry, I skipped a step. Jumped ahead. I'm going to say angle 1 and angle 3. I said 3, but I meant 2. I'm going to say angle 1 and angle 2 are supplementary. Angle 1 and angle 2 are supplementary. And I can see that here. They form this straight line. And I use this trick based on the linear pair theorem. So I looked back in my book, especially at the theorems that I learned in this chapter. One we talked about yesterday very briefly. We didn't go into much detail. That was the linear pair theorem. The linear pair theorem said these two angles form a linear pair, therefore they're supplementary. So angle 1 plus angle 2 is 180 degrees. They form a straight line. So now I have angle 1 and angle 2 are supplementary. And so if angle 1 and angle 2 are supplementary, what's my then statement that can follow from this? Well, then their sum is 180 degrees. Then the measure of angle 1 plus the measure of angle 2 is 180 degrees. So that'll be step 4. Measure of angle 1 plus the measure of angle 2 equals 180 degrees. And I know that based on my definition of supplementary angles. Definition of supplementary angles. So to go from step 3 to step 4, I just created an if statement. If angle 1 plus angle 2 are supplementary, then their measures add up to 180 degrees. All right? My 5th step says the measure of angle 1 plus the measure of angle 3 is 180. Well, how did I get that? I said if measure of angle 1 plus the measure of angle 2 is 180, and I look back to here and I say the measure of angle 2 is equal to the measure of angle 3. I'm going to box it in here. Well, then I can replace this box with what this is equal to with this box with what that's equal to. So I'm basically taking this measure of angle 3 and subbing in over here. I'm then saying measure of angle 1 plus the measure of angle 3 is equal to 180. Well, notice here on my 5th step, I just repeated what I had said when I was working backwards from my proven. I had worked backwards, I had worked forward, I got the same statement. So I know I'm on the right track. All I have to do here is fill in a reason. How can I say the measure of angle 1 plus the measure of angle 2 is 180? How do I go from that statement to this statement? The measure of angle 1 plus the measure of angle 3 is 180. Well, I use substitution. I substituted in the measure of angle 3 for the measure of angle 2 on this step. So I used substitution. That's my reasoning. And there you go. That's it. I have 6 steps to my proof. Using these 5 tips, I was able to start at number 1, state my givens, then state what I was trying to prove. So I was trying to prove this, so I said that. I created an if-then statement to come up with my next step on my statements. I had to do a little working backwards. I worked backwards a little. That way I knew where I was trying to go. I knew when I met up in the middle, and I knew my target. I think the biggest trick here is recognizing when do we need to pull out these theorems? When do we need to use our definitions, right? So looking at these theorems. Again, this will require you to look back in your book a lot for answers that you're trying to look for. This will require you to look at theorems and a little bit of cleverness, but typically if you can find these theorems to match up and say what you want to say, then you can put it all together and create a 2-column proof. All right, I hope that helped just a little using these 5 steps. Again, today we're going to practice numbers 6 through 12 on page 114. All right, page 114. And hopefully on these steps, you're not creating entire proofs like you are here. You're just substituting in parts of the proof, you know. You're only doing this part of step 2 or this part of step 3. All right, so look for those statements. Think of the if-then statements and practice those reasonings and follow these steps, and hopefully that helps you out.